Today we shall be looking at trigonometric identities. We are going to prove a whole lot of identities. It is a big challenge to students. I believe that by the end of this lecture, it will be a thing of the past, something which you see to be very easy and interesting. Now, let's consider a right angle triangle. Don't forget to bring the 90 degrees. So if this is A, let's say this is R, and then this is B. Now, from Pythagoras theorem, you can say that A square plus B square equal to R square. Now, let's suppose the angle over here is theta. So using the trig ratios, what can we say? Sine theta. Sine theta, that is opposite over hypotenuse. That is B over R. Cos theta, cos theta adjacent over hypotenuse, that is A over R. Tan theta, tan, that is opposite over adjacent, so we have B over A, that is tan theta. Now, tan theta is the same as, that is sine theta all over cos theta. Now, what is sine theta? We had sine theta to be B over R divided by cos theta, which is A over R. Clearly, we know that the second term would do what? Reciprocate. So you have R over A. Now this R will cancel that R, so you have B over A. Clearly, we know that the tan theta, which is B over A, we also have it over here, which is also B over A. Now, what can we also say from it? We know that sine theta is what? That is B over R. So clearly, what is B? We can say that, let's say this is 1, this is 2, this is 3, and then this is 4. Now, from 2, what can we say? We can say that B is equal to R sine theta. And then from 3, what can we say? We can say A is equal to R cos theta. And then what can we also say? Now, substituting, that is 2 and 3 into 1. We know 1 is what? A square plus B square equal to R square. Now, what is our A? Our A is R cos theta. So we have R cos theta square. What is our B? R sine theta. So R sine theta square. This is equal to R square. Now, we know that if you have AB to the power n, this is AN, BN. This implies we are going to get R square cos square theta plus R square sine square theta equal to R square. What can we see? We can see that R is a common factor, so we can divide through by R. And when we divide through by R, we get cos square theta plus sine square theta equal to 1. We divide by R square, R square, R square. So this is what we have. So we have an identity now with cos square theta plus sine square theta equal to 1. From here, this is a major identity. What can we say? We can say that cos square theta is 1 minus sine square theta. And then also, we can also say sine square theta equal to 1 minus cos square theta. Now let's note the following. Now if you have 1 over cos theta, this is equal to sec theta. And if you have 1 over sine theta, this is the same as cosec theta. If you have cos theta over sine theta, this is the same as cot theta, and this is the same as 1 over tan theta. Now, we know that cos square theta plus sine square theta is equal to 1. Now let's divide through with, that is cos square theta. This implies that cos square theta over cos square theta plus sine square theta all over cos square theta is equal to 1 over cos square theta. Now what can we say? Cos square theta divided by cos square theta, that is 1, is the same thing, so 1. Now we know sine over cos is tan, so it is telling us that 1 plus tan square theta. Now 1 over cos is sec is equal to sec square theta. So this identity, please don't forget about it, that 1 plus tan square theta is equal to sec square theta. We can also divide through by sine square theta. So the first one, cos square theta, I'll divide through by sine square theta. I'll divide this one by sine square theta. I'll also divide this by sine square theta. So I'll be getting, that is the first one, cos square theta over sine square theta plus sine square theta all over sine square theta equal to 1 all over sine square theta. Now cos over sine is cot, so that will be cot square theta. Sine over sine, that is 1. 1 over sine is cosec, so we have cosec square theta. Please, these identities are so important. Let us make sure we know how to generate them. By so doing, it will help you to be able to prove a whole lot of identities. Now let's say this past question says that the functions f and g are defined on the set of real numbers by f of x, moving from x, that is f of x is 1 minus x squared, and then g of x is 1 plus x squared. You should find first one f cos x, and then g of tan x. Now what do we know? We know f of x is 1 minus x squared. The first one is telling us to find f of cos x. And this f of cos x, so in place of x, wherever I see x, I have to put cos x over there. So this is 1 minus cos square x. Now, what is 1 minus cos square x? 1 minus cos square x is just sine square x. Why? We know sine square x plus cos square x is 1. So our sine square x is just 1 minus cos square x. So 1 minus cos square x is just sine square x. Now the second one, we know g of x to be equal to 1 plus x squared. Now what is g tan x? This is 1 plus tan square x. Now from our deduction, we're able to deduce that 1 plus tan square x is just equal to what? Sec square x. So this 1 plus tan square x is just sec square x. Now let's see the second example. Given that sine x is equal to p, you find an expression in terms of p for sec square x. Now sec square x, what is sec square x? Sec square x is the same as 1 all over sec square x is the same as 1 all over cos square x. 1 over cos is the same as sec. Now, but then what we've been given is we've been given sine x equal to p. It means that we have to let this cos square x be in terms of sine x. Now, cos square x is the same as what? 1 minus sine square x. It's 1 minus sine square x. Well, we know sine square x plus cos square x equal to 1. So from here, if we want cos square x, it will just be what? 1 minus sine square x. 1 over 1 minus. Now what is sine x? We're giving sine x to be p. So that will be 1 minus p squared. Now let's also note that cos square x is the same as cos x all square. Please let's note that cos square x is the same as cos x all square. Let's see this example 3. We are being told to prove that cot theta plus tan theta is equal to cosec theta sec theta. Now with this one, you can decide to start from the left hand side so that you'll be able to deduce the right hand side, or you can start from the right hand side and then deduce the left hand side. One thing that you should note at is that if you want to solve such questions, if you want to prove such questions, all that you're supposed to do is look at the part which is quite challenging or which is quite complicated, and then with that one you'll be able to prove the other one. So let's see, let me consider the left hand side. So we have cot theta plus tan theta. Now what is cot theta? Cot theta is the same as what? Cos theta all over sine theta. Now what is tan theta? Tan theta is the same as sine theta all over cos theta. From here we can find the LCM. What's the LCM? It's just the multiplication of the denominators. That is sine theta and then cos theta. This sine theta will cancel this sine theta. Cos theta times cos theta, this will be cos square theta plus, look at this, cos theta will cancel cos theta, sine theta times sine theta, and this will give us sine square theta. From here, this is just cos square theta. Now, what is cos square theta plus sine square theta? We're able to deduce that it is 1. So you have 1 all over sine theta cos theta. And this is just 1 over sine theta times 1 over cos theta. Now, what is 1 over sine theta? 1 over sine theta is cosec theta. Then what is 1 over cos theta? That is sec theta. Now, the question says that we should prove that this is equal to what? Cosec theta sec theta. And then we have been able to prove. Or let's try from the right hand side and try and see if we're able to prove the left hand side. So the right hand side, cosec theta sec theta. Now this is the same as 1 over cosec, that is what, sine theta, times 1 over cos theta. Now this is the same as just 1 all over sine theta cos theta. What is 1? We know that 1 is the same, because the angle is theta, 1 is the same as what? Sine square theta plus cos square theta. So that is sine square theta plus cos square theta all over sine theta cos theta. From here, this is the same as sine square theta over sine theta cos theta plus cos square theta all over sine theta cos theta. Now, why was I able to do this? We know that if you have a plus b all over c, this is equal to what? A over c plus b over c. So this, the property that I use, this is the principle that I use for this. Now, clearly, we can see that sine square theta, sine theta. So one of it will cancel, and we are going to get sine theta over cos theta. And then cos square theta, cos theta, one will cancel, so we have cos theta all over sine theta. Now, sine theta over cos theta, this is tan theta. And then cos theta over sine theta, this is the same as cot theta. Now, what is the question saying? The question is saying that we should show that cosec theta sec theta is the same as cot theta plus tan theta. And because addition is commutative, cot theta plus tan theta is the same as what? Tan theta cot theta. So clearly, this is just the same as cot theta plus tan theta. Now let's consider this example. We should show that 1 over 1 plus sine theta plus 1 over 1 minus sine theta is equal to 2 sec square theta. So in this case, let's consider the left hand side and see if we'll be able to prove to get the right hand side. So we have 1 over 1 plus sine theta plus 1 all over 1 minus sine theta. Now with this, what is the LCM? The LCM is just the multiplication of the denominator. So that is 1 plus sine theta, 1 minus sine theta. Now 1 plus sine theta will cancel 1 plus sine theta. And then we will be left with 1 minus sine theta. So we have 1 minus sine theta plus 1 minus sine theta will cancel 1 minus sine theta. So what do you have? You have 1 plus sine theta. Now clearly negative sine theta, positive sine theta will go away. 1 plus 1, we have 2. All over, let's see, we have 1 plus sine theta, 1 minus sine theta. Now note that this is difference of 2 squares. So clearly we are going to get 1 square minus sine square theta. Now we know sine square theta plus cos square theta is the same as what? 1. So clearly here 1 minus sine square theta is the same as, so here this is the same as cos square theta. And this is the same as 2 times 1 all over cos square theta. And what is 1 over cos? 1 over cos is sec. So this is the same as 2 sec square theta. So we've been able to prove that the left hand side is equal to the right hand side. We want to show that tan square theta is the same as sine square theta into 1 plus sec square theta. So with this, it is advisable, the complicated part is this. Let's try to see if we'll be able to prove that the right hand side is equal to the left hand side. So we have sine square theta 1 plus tan square theta. And here, so we have our sine square theta. Now, what is 1 plus tan square theta? We were able to deduce that 1 plus tan square theta is the same as what? Sec square theta. So you have sine square theta. Now, what is sec square theta? Sec square theta is the same as 1 all over cos square theta. And this is just the same as sine square theta over cos square theta. And what is sine square theta over cos square theta? This is tan square theta. So we've been able to prove that this is equal to that. Or the same point, you see we have sine square theta 1 plus tan square theta. Now our sine square theta 1 plus, now tan square theta is the same as sine square theta all over cos square theta. We can find the LCM here. So we have sine square theta. Our LCM is cos square theta. This one can be written as 1 over 1. 1 will go into cos square theta, that is cos square theta, plus this will cancel this. So what do you have? We have sine square theta. Now what is cos square theta plus sine square theta? That is 1. So in a nutshell, we have sine square theta times 1 all over cos square theta. And this is the same as sine square theta over cos square theta. And sine over cos is tan. So this is tan square theta. Now I want to prove that sec A plus cosec A minus cot A is equal to tan A. Now the complicated part is the left hand side. So let's try from the left hand side and show if this will be equal to the right hand side. So we have sec A cosec A minus cot A. Now sec A is giving us, that is 1 over cosec A. Sec A is 1 over cos A. And then cosec A is 1 over sine A minus. Now what is cot A? Cot A is the same as cos A over sine A. Now this is the same as 1 all over cos A sine A minus cos A all over sine A. Now what is the LCM? What's the LCM? The LCM is cos A sine A. Now the first one, cos A sine A, will cancel out that cos A sine A. So they have 1. And then sine A will cancel the sine A here. What is left? Cos A. Cos A times that, we have cos square A Now, we know sine square A plus cos square A is 1. So clearly this 1 minus cos square A, this is the same as sine square A all over cos A sine A. Now, we have sine square A, we have sine A. So sine A will cancel one of this. So you have sine A all over cos A. And what is sine A over cos A? This is just tan A. So we've been able to prove that the left hand side is equal to the right hand side. Now this example 7, you are supposed to show that 1 minus cos square theta all over sec square theta minus 1 is equal to 1 minus sine square theta. Now what is 1 minus cos square theta? 1 minus cos square theta is the same as what? Sine square theta. So you have sine square theta all over. Now let's see, we have sec square theta minus 1. Now we know that 1 plus tan square theta is the same as what? Sec square theta. So it means that tan square theta is sec square theta minus 1. So this sec square theta minus 1 is tan square theta. Now, this is the same as sine square theta. Now, what is tan square theta? Tan square theta is the same as what? Sine square theta all over cos square theta. So you have sine square theta. Division will change to what? Multiplication. So you have cos square theta all over sine square theta. Okay, what can we see? Sine square theta will cancel sine square theta. What is left? Cos square theta. But then the question says we should show that it is equal to 1 minus sine square theta. And cos square theta is the same as what? 1 minus sine square theta. Why? Sine square theta plus cos square theta is equal to 1. So cos square theta is equal to what? 1 minus sine square theta. Now let's say this example. It says that we show that cos theta into 1 over 1 minus sine theta minus 1 over 1 plus sine theta can be written in the form k tan theta. And we should find the value of k. So let's see cos theta into bracket 1 over 1 minus sine theta minus 1 over 1 plus sine theta. We can find the LCM with the 1 in bracket. So we have cos theta. Now let's see the bracket. What is the LCM? 1 minus sine theta, 1 plus sine theta. Clearly 1 minus sine theta will cancel 1 minus sine. What is left? 1 plus sine theta. So we have 1 plus sine theta. What do you have here? Minus 1 plus sine theta will cancel 1 plus. What is left? 1 minus sine theta. So we have 1 minus sine theta. Now we have cos theta, and then the numerator 1 plus sine theta minus 1 plus sine theta all over 1 minus sine theta 1 plus sine theta. Now this one and that one will cancel out. Sine theta plus sine theta, that will be 2. So you have cos theta times 2 sine theta all over. Now let's see the denominator. We have 1 minus sine theta times 1 plus sine theta. This is difference of 2 squares. So we just take the negative, we square both. So you have 1 square minus sine square theta. Now we have cos theta times 2 sine theta all over. What is 1 minus sine square theta? 1 minus sine square theta is the same as what? Cos square theta. 1 cos will cancel 1 cos, so we have 2 sine theta over cos theta, and this is just 2 tan theta. We are being told to express it in the form k tan theta, and clearly this is in the form k tan theta. So our k is basically 2. Now let's say this example. We are being told to prove that cot x plus tan x into bracket cot x minus tan x is equal to 1 over sine square x minus 1 over cos square x. Clearly the complicated part is the left hand side. So we can show from the left hand side so that we can get the right hand side. Now let's see, we have cot x plus tan x cot x minus tan x. Now what can we see here? We have cot x plus tan x, cot x minus tan x. This is difference of two squares. We know that if you have a square minus b square, this is a minus b, a plus b. So clearly, if you have a minus b, a plus b, the negative was taken and each of them were squared. So clearly, let's take the negative, we take the negative one and then we squared. So this is just equal to cot square x minus tan square x. Now what is cot square x? Cot square x is the same as cos square theta all over sine square theta, and tan square theta is the same as sine square x. The angle is x minus cos square x. Now what is the LCM? The LCM is basically sine square s cos square x. Now what can we see? Sine square s will cancel sine square s. What is left? Cos square x, and cos square s times cos square x. That is cos square x or square, or cos to the power, or cos 4x. Now minus this cos square s will cancel cos square s. What is left? Sine square x times that. So that will be sine square x all square. Now what can we see? This is just difference of two squares. So this can be expressed as cos square x minus sine square x into bracket, another one sine square x plus cos square x all over sine square x cos square x. Now, so what can we see clearly from it? Sine square x plus cos square x is 1. So we have cos square x minus sine square x all over sine square x cos square x. And sine square x plus cos square x is just 1. Now, what do we want to prove? We want to prove that this is equal to 1 over sine square x minus 1 over cos square x. So clearly from here, this is just equal to cos square x all over sine square x cos square x minus sine square x all over sine square x cos square x. How did I do this? If you have a plus b all over c, this is a over c plus b over c. So what can we see? Cos square s and cos square s are the same, so this will cancel out that, this will also cancel out that. So you have 1 over sine square x minus 1 all over cos square s as required. So that's how we did. We saw that the first part, just the multiplication, is difference of two squares. So that gave us this. You can also decide cot x, that is what cos x over sine x, tan s sine x over cos x, and then you do the same thing, you manipulate and you'll be able to get it. Example 10, show that 1 over 1 minus cos theta minus 1 over 1 plus cos theta is equal to 2 cosec theta cot theta. Now, from this, the complicated part is the left hand side. So let's show that this is equal to the right hand side. So you have 1 over 1 minus cos theta minus 1 over 1 plus cos theta. Now, what is the LCM? The LCM is 1 minus cos theta, 1 plus cos theta. What can we see? 1 minus cos theta will cancel 1 minus cos theta. 1 plus cos theta will multiply the top ones. We have 1 plus cos theta minus 1 plus cos theta will cancel 1 plus cos theta. So what do you have? 1 minus cos theta. Now, looking at the numerator, we have 1 plus cos theta. Negative times positive 1, that's negative 1. Negative times negative, that is positive cos theta. All over, let's look at the denominator. What are we seeing? 1 minus cos theta times 1 plus cos theta. Clearly, this is difference of two squares. So this is just 1 minus cos square theta. Please, difference of two squares is so important. So let's try and get it. Now, 1 will cancel negative 1. Cos theta plus cos theta that is 2 cos theta, all over, now let's see, 1 minus cos square theta. 1 minus cos square theta is what? Sine square theta. Now, we are being told to show that this is equal to what? 2 cosec theta cot theta. And this is the same as 2 cos theta all over sine theta times sine theta. Now, this is the same as 2 times 1 over sine theta times cos theta all over sine theta. Now, what is 1 over sine theta? 1 over sine theta is the same as 1 over sine theta is the same as cosec theta. And then cos theta over sine theta is what? Cot theta. So this is just equal to 2 cosec theta cot theta, as was asked. We have proved that sine A over 1 plus cos A plus 1 plus cos A over sine A is equal to 2 cosec A. Now, clearly, the complicated part is the left-hand side. So let's try and then show that it is equal to 2 cosec A. Now we have our sine A over 1 plus cos A plus 1 plus cos A all over sine A. What's the LCM? The LCM is 1 plus cos A. And then we have sine A. This is the LCM. What can we see? 1 plus cos A will cancel 1 plus cos A. What is left? Sine A. Sine A times sine A. This will give us sine square A. Sine A will cancel sine A. What is left? 1 plus cos A. 1 plus cos A times 1 plus cos A. That is 1 plus cos A all square. Now, we have sine square A plus 1 plus cos A all square. This is just 1 plus 2 cos A plus cos square A all over. Let's see the denominator. We have 1 plus cos A sine A. Now with the expansion, I know A plus B all to the power 2. This is A squared plus 2AB plus B squared. So that's what I use to expand the numerator. Now, I can see sine square A plus cos square A. What is it? That is 1 plus this 1 plus 2 cos A all over 1 plus cos A sine A. Now what is 1 plus 1? That is 2 plus 2 cos A. All over, you have 1 plus cos A. So you have 1 plus cos A sine A. Wow, you can see 1 plus cos A. You can see 2 plus 2 cos A. What can we see? When you factorize 2 out, you'll be getting 1 plus cos A. So factorizing 2 from the numerator, we have 1 plus cos A all over 1 plus cos A. And then we have sine A. Now, 1 plus cos A will cancel 1 plus cos A. So what do you have? 2 all over sine A. This is the same as 2 times 1 over sine A. And this is just 2 cosec A. And this is what we were asked to prove. We're going to prove that into bracket 1 plus sine theta over cos theta all to the power 2 plus 1 minus sine theta over cos theta all to the power 2 is equal to 2 plus 4 tan square theta. Now clearly it is better for us to start from the left hand side to see if we'll be able to deduce the right hand side. So let's see the left hand side. That is 1 plus sine theta over cos theta all to the power 2 plus 1 minus sine theta over cos theta all to the power 2. Now what do we know from indices? If you have A over B all to the power n, we say this A to the power n, B to the power n. So we apply the same principle here. 1 plus sine theta all to the power 2 all over cos square theta plus 1 minus sine theta all to the power all over cos square theta. Now, we know that if you have a plus b to the power 2, it is a square plus 2ab plus b square. Expanding this is 1 plus 2 sine theta plus sine square theta all over cos square theta plus, expanding this is 1 minus 2 sine theta plus sine square theta all over cos square theta. Now, what is the LCM here? The LCM is cos square theta. So clearly, when you take the LCM, we are going to get cos square theta. So the numerator becomes 1 plus 2 sine theta plus sine square theta plus 1 minus 2 sine theta plus sine square theta. Now clearly, what can we see? 2 sine theta is cancelling out this 2 sine theta. What do you have? 1 plus 1. So we have 1 plus 1 plus sine square theta plus sine square theta all over cos square theta. Now 1 plus 1 is 2. Sine theta plus sine square theta, that is what? 2 sine square theta all over cos square theta. Clearly, what is the question asking us? The question is asking us, we should show that we have what? 2 plus 4 tan square theta. But in this case, what do you have to? When we divide, now we wouldn't be able to get a 2 because we have over cos square theta. But then here we'll be able to get the tan square theta. So what should we do? We can factorize this 2 out. When you factorize the 2 out, what do you have? 1 plus sine square theta all over cos square theta. Because here we wouldn't be able to get a 4. Now what is 1? 1 is the same as sine square theta plus cos square theta. Plus the sine square theta all over cos square theta. Now sine square theta plus sine square theta, this is what? 2 sine square theta. So you have 2 to bracket cos square theta plus 2 sine square theta all over cos squared theta. We can multiply through with the 2, and when we expand, we are going to get 2 cos squared theta, 2 times 2, that is 4 sine squared theta all over cos squared theta. What do we know? We know that if you have a plus b over c, this is the same as a over c plus b over c. So this is just the same as 2 cos squared theta all over cos squared theta plus 4 sine squared theta all over cos squared theta. Now this and that will cancel. So what do you have? 2 plus we have 4 sine squared theta over cos squared theta. That is tan squared theta. And this is what we were asked to prove. Now let's see this question. Given that a is equal to sec x plus cosec x and b is equal to sec x minus cosec x, we are being told to show that a square plus b square is equal to 2 sec square x cos square x. Now, what is our a? Our a is sec x plus cosec x. But then they are telling us to show that a square plus b square. So all that we need to do is to square the a. So a square, that is we have sec x plus cosec x all square. Now, this square is of the form a plus b also, which is a square plus 2ab plus b square. So this is just sec square x plus 2 sec x cosec x plus cosec square x. That is our a square. Now, what is b? B was giving us sec x minus cosec x. So our b square Now let's square, and then let's expand. We know that if you have a minus b all squared, it's a squared minus 2ab plus b squared. So this is just sec square x minus 2 sec x cosec x plus cosec square x. That's our b squared. Now what is it telling us? It says that you show that a squared plus b squared is this. Now what is a squared plus b squared? So if I have a squared plus b squared, let's see, sec square x plus sec square x. This is 2 sec square x. But 2 sec x cosec x will cancel out negative 2 cosec x, sec x cosec x. Then cosec square x will give us 2 cosec square x. So that is our a square plus b square, sec square, that will be 2 sec square x. Now, 2 sec x cosec x, this and this will cancel out. But let's see, cosec square x, cosec square x. When you add this, this will give us 2 cosec square x. So you have 2 cosec square x. Now we are being told to show that it is equal to 2 sec square x cosec square x. What can we do? We can factorize out the 2. When you factor the 2, we have what? Sec square x plus cosec square x. Now, what is sec square x? Sec square is the same as 1 over cos square x. Cosec square x is the same as 1 over sine square x. I'll factor 2 outside. What's the LCM? The LCM is just cos square x sine square x. What can we see? Cos square will cancel cos square. What is left? Sine square x. Sine square x will cancel sine square x. What is left? Cos square x. Now what is sine square x plus cos square x? That is 1. All over we have cos square x sine square x. And this is just the same as 2 times 1 over cos square x times 1 over sine square x. Now, what is 1 over cos? This is sec square x. And what is 1 over sine? This is cosec square x. The question says that we should show that this is equal to what? A square plus b square is equal to 2 sec square x cosec square x. And clearly, we have been able to show that. Now let's consider this past question. This is May 2017, question number 9a. We are being told to simplify cos theta plus sin theta all over cos theta minus sin theta minus cos theta minus sin theta all over cos theta plus sin theta, and express the answer in terms of tan theta. Now what can we see over here? We have to find the LCM. Now what is the LCM? The LCM is basically the multiplication of the denominators. So we have cos theta minus sin theta, cos theta plus sin theta. Now let's see, cos theta minus sin theta is cancelling out cos theta minus sin theta. Cos theta plus sin theta multiplied by this. So this is just cos square theta plus sin theta all square. This has cancelled this, so this will multiply that by the same, so to the power 2 minus. Now let's see, cos theta plus sin theta will cancel cos theta plus sin theta. We have cos theta minus sin theta, so this will multiply the numerator here, and this is just cos theta minus sin theta all square. Note the denominator is just difference of 2 squares. Now expanding the numerator, we know if you have a plus b all to the power 2, it is a squared plus 2ab plus b squared. So expanding this, that will give us cos squared theta plus 2 cos theta sin theta plus sine squared theta. That is expanding the numerator. Now let's expand the other one. This is just cos squared theta minus 2 cos theta sin theta plus sine square theta all over. Please take note of the denominator. We have cos theta minus sin theta, cos theta plus sin theta. So clearly, this is the difference of two squares. So the down is just cos squared theta minus sine square theta. Now, with this, let's see the numerator. So clearly, expanding, we have cos squared theta plus 2 cos theta sine theta plus sine square theta minus, when we expand with the negative, that will be negative cos squared theta plus, negative times, that is plus. So that will give us 2 cos theta sine theta minus sine square theta. All over, we have cos square theta minus sine square theta. Now, what can we see? Cos square theta, or clearly this and this is cancelling, this and that is also cancelling. So we have 2 cos theta sine theta, we have 2 cos theta sine theta. So that will be 2 cos theta sine theta plus 2 cos theta sine theta. All over cos square theta minus sine square theta. Now, what can we see over here? 2 cos theta sine theta, 2 cos theta sine theta. Adding the 2, that will be 4 cos theta sine theta. All over cos square theta minus sine square theta. Now, the question is saying that we should simplify this and express the answer in terms of tan theta. So we have been able to simplify. Over here, there's nothing for us to do. And then it says that we should express our answer in terms of tan theta. Looking at it, should I divide through by sine or cos? Now, when I divide through, I know that tan is sine over cos. So it is better for me to divide through with the cos so that I can express it in terms of the tan. So when I divide through, with cos square theta, what do I have? I have 4 cos theta sine theta all over cos square theta. That's the numerator divided by denominator. So this is the numerator. We have cos square theta all over cos square theta minus sine square theta all over cos square theta. Now, cos theta will cancel 1 cos theta. So we have 4 sine theta all over cos theta, because cos theta has cancelled 1, divided by, here, what do you have here? 1 minus sine square theta all over cos square theta. Now, what is sine theta over cos theta? That is tan theta. So we have this to be equal to 4 tan theta all over 1 minus sine over cos is, we have tan square theta. So we have been able to express it in terms of tan theta. Now let's see this. It says that we should prove the identity sine square theta plus 2 cos theta minus 1 all over sine square theta plus 3 cos theta minus 3 is equivalent to cos theta over cos theta minus 1. Now, it is telling us that our numerator should be in terms of cos. Our denominator should also be in terms of cos. So I have sine square theta, I have to change this in terms of cos. I have sine square theta, I have to change it in terms of cos. So let me start with the left-hand side. So I have sine square theta plus 2 cos theta minus 1 all over sine square theta plus 3 cos theta minus 3. Now, I have to change this. I know sine square theta plus cos square theta is equal to 1. So sine square theta is just 1 minus cos square theta plus 2 cos theta minus 1 all over, let's see the denominator. Sine square theta is 1 minus cos square theta plus 3 cos theta minus 3. Now, looking carefully at the numerator, this will cancel out that. So I have negative cos square theta plus 2 cos theta. So let me write the positive one. So 2 cos theta minus cos square theta all over. Now let's say this and that is giving me 1 minus 3. That's negative 2 minus cos square theta plus 3 cos theta. Now let's see the denominator. I can factorize negative out so that this negative will go and multiply the numerator. In a nutshell, let me write it. 2 cos. I want to factorize negative from the numerator. When I factorize negative from the numerator, I'll get this. Cos square theta minus 2 cos theta. I factorize negative out. This time this will give us this. This time this will give us this. Now let me also factorize negative out. So negative out, I'll get 2 plus cos square theta minus 3 cos theta. Now this and that will cancel. Let's look at the denominator. The denominator, we are getting a quadratic equation. So let's put it in standard form. That is ax squared plus bx plus c. So with this we have, this is the same as cos theta minus 2 cos square theta. Okay, so the down one, that is, I'll bring the cos square theta first, minus 3 cos theta plus 2. Now, the question is saying that we have to shoot in terms of what? Cos theta over cos theta minus 1. Clearly, looking at the denominator, we can factorize the denominator. This in quadratic form. So two numbers, when you multiply, you get 1. When you add, we can get negative 3. That is negative 2 and then negative 1. So the denominator, only the denominator, we have cos square theta minus 3 cos theta plus 2. Factorizing this, that is cos square theta minus cos theta minus 2 cos theta plus 2. This time this will give us 2, this plus this will give us negative 3. So clearly what is common? Cos theta is common. So we have cos theta minus 1 minus 2 cos theta minus 1. Now cos theta minus 1 is common. Let me factorize it out. So I have cos theta minus 1 and then I have cos theta minus 2. Therefore, cos square theta minus 2 cos theta all over cos square theta minus 3 cos theta plus 2. The numerator, I have cos square theta minus 2 cos theta all over. Denominator, what did I get? I had cos theta minus 1 cos theta minus 2. Clearly, what can I do at the numerator? I can factorize cos theta out. And when I do that at the numerator, when I factor cos theta out, what am I getting? I'll get cos theta minus 2 all over cos theta minus 1 cos theta minus 2. Clearly, cos theta minus 2 is cancelling out cos theta minus 2. So what do you have? We have cos theta all over cos theta minus 1. And this is what we were asked to prove. Let's consider this example. It says that we should prove that cos theta over 1 minus tan theta plus sine theta over 1 minus cos theta equal to sine theta plus cos theta. Now, the complicated part is the left-hand side. So let's try to prove from the left-hand side so that we'll be able to get the right-hand side. Now, we have cos theta. So cos theta all over. Now, let's see this. We have 1. But then the tan theta is what? It can be expressed as sine theta over cos theta plus. Here we have sine theta. 1 minus cos theta. So that is 1 minus cos theta all over sine theta. Now, the numerator we have cos theta, but then the denominator we can find the LCM, which is cos theta, but this is over 1. So we are going to get cos theta. Cos theta will cancel cos theta, so we have minus sine theta. That's the denominator. Plus, we have sine theta all over. Now, the denominator, let's look for the LCM, which is sine theta. This is over 1. When we go into sine theta, that's sine theta times 1. So this will give us sine theta. Now let's see, sine theta will cancel sine theta. So minus cos theta. Now, with this is just, you know that this is just the same as cos theta divided by cos theta minus sine theta all over cos theta plus sine theta divided by sine theta minus cos theta all over sine theta. Now, if division is in, what can we do? Division will change to what? Multiplication. So clearly, this is just cos theta times cos theta all over cos theta minus sine theta plus the other side too, we have sine theta times, we have sine theta all over sine theta minus cos theta. Now what is cos theta times cos theta? This will give us cos squared theta all over cos theta minus sine theta plus sine theta times sine theta. This is just sine squared theta all over sine theta minus cos theta. We have cos theta minus sine theta, we have sine theta minus cos theta. We can factorize the negative out here so that this will change to negative, so that the denominator will be the same thing. So we have cos squared theta all over cos theta minus sine theta minus, I have sine squared theta. Look at this, so the denominator will change to cos theta minus sine theta. Negative times, there's always negative, negative times positive, that will be that. So here the denominators are the same. So let me find the LCM, which is cos theta minus sine theta. That is the LCM. Clearly, this will cancel out this. So what do you have at the numerator? Cos squared theta minus sine squared theta, because this one will cancel this, and then we are left with that. Now the numerator is difference of two squares. So clearly from this side, this is just the same as cos theta minus sine theta, and then we have cos theta plus sine theta all over cos theta minus sine theta. Now cos theta will cancel what? Cos theta. So what do you have? Cos theta plus sine theta as required. And that is very trivial. Now let's consider this example. That's example 17. It says that by using the identity tan squared theta plus 1 equal to sec squared theta, or otherwise, we should prove the identity sec to the power 4 theta minus sec squared theta. We should prove that this is equal to tan 4 theta plus tan squared theta. So either we use this to this side or this side to that side. Now let's try from this side to that side. Now we have sec 4 theta minus sec squared theta. Now what do you have here? This is sec squared theta. So let's try and transform this to that. So this one is the same as sec squared theta all to the power 2 minus sec squared theta. And now what is sec squared theta? Sec squared theta is given to us as what? Tan squared theta plus 1. All squared minus sec squared theta, which is what? Tan squared theta plus 1. Now, with this, it is of the form a plus b all to the power 2, which is a squared plus 2ab plus b squared. So expanding this is just tan squared theta plus 2 tan squared theta. That is a squared, so that is a squared plus 1 squared minus tan squared theta minus 1. Now what do you have here? This is just tan to the power 4 theta plus 2 tan squared theta plus 1 minus tan squared theta minus 1. This one and that one will go away. 2 tan squared theta minus tan squared theta. So we just have tan 4 theta plus 2 tan squared theta minus tan squared theta. It is just tan squared theta. And then we'll be able to prove. Now we are being told to prove that sine x over 1 plus cos x is equal to 1 minus cos x over sine x. Clearly, how can we get the numerator here? We have sine x. What about when you consider the conjugate of the denominator of the left hand side? Now let's see, we have sine x over 1 plus cos x. Now we'll consider the conjugate of the denominator. So you have sine x all over 1 plus cos x times 1 minus cos x all over 1 minus cos x. Clearly we are getting the numerator. Now looking at this, we have sine x and then this 1 minus cos x. But then the denominator is difference of 2 squares. So clearly this is what? 1 minus cos square x. Now what is 1 minus cos square x? 1 minus cos square x is the same as sine square x. 1 minus cos square is the same as sine square x. And looking at what we are supposed to prove, clearly this sine x becomes one of this. So we have 1 minus cos x all over sine x as required.